Okay, so let's go ahead and take a look at this problem set. So I'm not going to do like exactly like all of them word for word, but I am going to give you guys some hints on what you're supposed to do. When you guys look at any review assignment, you have to know what the question is asking. And obviously, like, this is the first derivative, right? And this is the second derivative. And so that's pretty clear. But in the end, like, when we start to look at other things, and you have to know what you're supposed to do. So the first thing I will do is just as a reminder. So in the first section, we talked about implicit differentiation. So when I take this derivative, it's y times the derivative of x plus your x squared times the derivative of y, which ends up having a dy dx next to it. And then a minus 4, and then a plus 2y dy dx is equal to 0. And then I group all the dy dx terms on one side and everybody else on the other. So x squared plus 2y dy dx is equal to 2xy plus 4. And that should be a negative 2xy. So the dy dx is equal to negative 2xy plus 4 over x squared plus 2y. Remember, this is a product rule of two variables. Okay. Okay, now second derivative. The only thing that you just have to remember is anytime you take the derivative of y, you have to write dy dx. And dy dx you already found up here. So you're going to have to substitute that in, which is going to be a big fat mess. Okay. Write the equation of the tangent lines where the x-coordinate is 1. Well, because your derivative has both x's and y's here, you're going to have to figure out what happens when you plug in 1 in for all your x's. You're going to have to solve for y. Then plug x and y into dy dx, which gives you the slope of the tangent line. Okay. Here, dy dx, just remember this is a product rule. Factor out the 4, put it with the 4x, completely up to you. You get the same answer. Horizontal tangents is when dy dx is equal to 0. Write the equation of the tangent line, you need dy dx at negative 4 comma 14. And then you want point slope form. And then when you do your point slope form for part D, what I'm trying to figure out is what y is equal to. So when I go y minus y1 is equal to m times x minus x1, right? This is your dy dx at x is equal to 4. This is, what is it? 14, right? And then your x value was negative 4. So that's negative 4. And then what you're actually solving for is this k right here is actually your y. So this becomes k. And then it's just like linearization. Here, normal line, so that is find f prime and then find opposite reciprocal. To find the normal line slope. Max and min, so this is looking for a maximum. So you need the derivative, and it's the first derivative. You need critical numbers. You need the chart. Then you need the coordinate points. Okay. Same thing. You can use the chart. You can say by the chart in part B, then whatever. Okay. And that is it for this lesson.